guys, Hofbauer. It's really still Labor Day Sunday, but I changed my shirt so I'll look like it's a new video, okay? Smushed my hair all over to one side here. Anyway, today we're going to talk about critical values and we're going to do a bunch of stuff on the graphing calculator. So please grab your calculator. If you need to pause the video before you're ready for that. I should have put a slide that said that at the beginning. All right, so I think I have mine down here ready to go. I probably should have typed stuff in already, but I didn't. So I'll clear all this out. All right, we're going to do a bunch of stuff on the graphing calculator in a minute, but first we're just going to talk about it from looking at a picture. So critical points are points on the graph where the graph of a function changes its direction or even just changes its shape. Now, direction is when it if you go left to right, this one goes up, then it hits a maximum value or a relative max, and then it turns around and goes down, and then it changes shape a little bit here, and then it keeps going down, and then it changes direction and goes back up. So extrema, okay, are points where the graph changes direction. We don't use that word extrema very often. We just call them maxes and mins. And the function has a maximum or minimum value, and it can be a relative or absolute max and min, and we'll talk more about those on the next slide at these points, okay? So this one is as high as it ever goes in this general area, so it's called a relative maximum. This one is as low as it ever goes, it's a relative minimum. Now, because this graph continues forever up and down, it doesn't have any absolute maxes or mins. And a point of inflection is where the graph changes its bend or shape, but not its direction, okay? We are going to call this bend, shape. We are eventually going to call this concavity, okay? Where it changes its concavity. All right, I am going to go to the next slide. And so on this graph right up here, you will notice it in this general area, this is as high as the graph ever gets, but over here, it does get higher before it changes direction. So it goes, if we go left to right, it goes up and turns around, changes direction. It got only so high here, but then eventually it got higher over here before continuing to only go down. So this is a relative maximum. It only is a maximum within this area. The absolute maximum is the absolute highest y value the graph ever hits. And a lot of graphs don't have absolute maxes and mins, but this one is all going down, so it does have an absolute max, the highest it ever gets somewhere. So a point with the greatest value compared to points around it is called a local max or a relative max. I kind of like the term local better because that means it's in this location only. When the greatest value over the entire domain of the function is the highest it ever gets, then it's the absolute max. All right, if we go over here, when the graph goes up on both ends, okay, then it has a minimum somewhere, and this one actually has an absolute minimum, and then in this area it has a relative minimum or a local minimum. So locally in this little area, this is the lowest it ever gets. But overall, it goes absolutely down to this y value, and that would be the absolute min. Min is just at the bottom, max is at the top. Okay? So give the coordinates and classify the extrema for the graph shown. Use your graphing calculator to approximate if needed. So it appears that this graph has a minimum, okay? And it is an absolute minimum because it doesn't ever come back down anywhere else on the graph. And when you state these, it is the value of the function. So the y value is 1, 2, 3, 4, 5. I'm going to go with, it has a min, it's an absolute min, of the minimum y value it hits was -5, okay? And that occurs at the x value of 1, 2, 3, 4, -4. Nope, +4, just kidding. All right, so if we wrote an ordered pair here, we'd have 4, -5. But the value of the function is -5 when x equals +4. This graph keeps going down forever, so it has a max here and a max here where it changed direction again. But this is the absolute highest, so it's an absolute max. And the ordered pair there, we should get off the calculator, I think. And it has a max here that is going to be a relative or local max. And we're going to get that value off the calculator. But guys, it also has a min here because it changed direction here in order to come back up again. So this little bump is a relative min, and it's not absolute min because the graph goes down forever. It doesn't have an absolute min. All right, so we need to find those 3 ordered pairs on the calculator. So I'm going to open up my calculator, and I just estimated on the last one. I don't really know for sure if that was at the ordered pair, but I'm going to go with it. But I'm going to practice on this one graphing. Negative x to the 4th, arrow to the right, plus 4x squared, or to the 2nd, minus 2x minus 4. All right, hopefully we get a graph that looks like that. So I'm just going to do a zoom 6. Looks pretty darn good. But now I want to find all of those ordered pairs to the nearest, and it doesn't really say, I'm going to go 100th. So what I need to do is to calculate, which is second trace, and then I need to pick min and max. I'm going to start on the left, so I'm going to do this max. So I'm going to pick number 4. Then what it wants, if you notice down at the bottom of the screen here, it says what is the number you want to pick to the left, and then when we hit enter, it's going to say to the right. I want to approximate. This is somewhere between an x value of like -3 and -1. Now you can scroll around, but I prefer you to type. It is somewhere between, and you could say -2 and -1 and it would work fine. Let's say -3, enter, -1, enter, and you get these 2 lines on the screen. If you have an older calculator, you only get these 2 arrows at the top, but somewhere in between there, I'm looking for a maximum value. And then what your calculator does is it tries values in there in little increments until it finds the highest y value. Guess is not that important. I got -1.52. I'm going to move that over here for a second because I'm going to do it one more time. I just want to show you that if I had done trace and picked maximum and said, you know what, let's look between only -2 and -1, picked a little bit closer window of in between there, and I could even scroll up here, I might get just a slightly different answer. Now, make sure you push enter and you don't have a guess down here. It should actually say maximum. If I move this over here, I don't think we got a difference. Well, maybe we did out here at the end. Okay, but very, very close. It's an estimate, but to the nearest 100th, we're good. All right, so I'm going to delete that one. And I'm going to delete this one, but first I'm going to write this ordered pair down. Up here we got -1.53, 2.94. All right, and then I'm going to delete that guy. Now I'm going to do this min next. You could do the other max. It doesn't matter the order you do them in. I'm going to go second trace and pick min. and it is down here. I could say it's somewhere between -1 and +2, or I could just trace along here until I get a good guess. I'm just going to hit enter and go. You want to go past the min and where it's going up again. So somewhere in between there, I want to figure out the minimum value. And I got 0.26, comma, -4.25. And that was the minimum. Then I'm going to find this maximum and write that out here. The relative max right up here. And so we go second trace, find a maximum, number 4, and you could hit enter and pick this spot, and then you want to go clearly to the right of where you started so that in between those two spots it's finding the maximum. Okay, hit enter, make sure it looks like it's right at your top spot where it says maximum there, and you get 1.26 and 27 and -2.69. Ugh, I made a mess. Make sure I have that right. Okay. I did want to show you real quick. If you do, second calculate, and you say I want to find a minimum, and you pick, say, between here and here. Accidentally, you pick them really close together. It will find a minimum value. But clearly that's blinking is not a minimum on the graph. Okay, so be real careful that it lands at the minimum on the graph, and that will help you make sure you didn't accidentally hit enter too many times somewhere. It should be blinking down here at the bottom, up here at the top of that peak, the top of that peak when it says max and min. All right, again, that's just because of the boundaries we picked. I got it wrong. All right, now I'm going to scroll up, and we need to list these correctly. We are going to say it had a relative min, and it is the y value of the function. So of -4.25, and that occurred at x equals 0.26. I don't know why I started with that one, but now we'll do the two maxes, I guess. It had an absolute max of, and it's the y value, 2.34. Is that what that said? 2.94. I can't read my own writing. And that occurred at x equals -1.53. And then it had a relative max, or a local max, of, and the y value is -2.69, and that occurred at an x value of 1.27. All right, so that's how you write maxes and mins, and that's how you use your calculator to find them. I think I have some more examples here. Let's do one more on the calculator, and then maybe for number 4, we'll just estimate and pretend we did it on the calculator. I don't want to spend too much time because it takes me forever to do these on the calculator. All right, because I'm slow. So, okay, negative x to the third minus 5x squared minus 3x plus 4. Again, the window they're showing this in is just going out maybe 10 each direction, so a zoom 6 should work. All right, what are we looking for? Looks like one max and one min. If we start on the left, this would be a min. So second trace minimum, number 3. And it looks to me 1, 2, 3, 4, like it's between -4 and maybe -2. So I'm going to type the left boundary of -4, and the right boundary of -2, and I think it's happening somewhere in between there. So it looks to me that it happens exactly at -3, -5. We have a little bit of calculator error going on, but it looks good on the graph. -3, -5 down there. And then the maximum looks like it might be some decimals. So if we do second trace max, and we pick values from maybe -2 again, over to +1. So somewhere in between those two lines, I want it to find that peak or maximum. And it looks like it's about -1/3, -0.33, comma. We are just estimating it to the nearest hundredth, 4.48. All right, so I'm going to write these out. This one is a min. Now, is it an absolute min? Well, over here there's an arrow that goes down forever. So this is just a local or relative min. And the value of the function is -5, and that occurs at x equals -3. And then up here we had a relative max because the arrow's going up. It does continue up. But in this general localized area, it had a direction change at here, and the value of the function is 4.48, and that occurs at x equals -0.3. All right, I vote we just run through this one by estimating. I'm going to say this is like -1.2 or 3. And +1, 2, 3, 4, 5, 6. I wrote over it so I can't tell. Maybe it went only to 5.8 or something. This point, guys, is an inflection point. It changed direction, but it's not a max or min. We're going to talk more about those in the second half of the video. And then over here, we have a relative min. And that occurs... I'm going to go with, it occurs at 1.2 and 0. All right, these are estimates because didn't want to spend time finding them all in the calculator. But you would state it has a relative max value of 6 that occurs at x equals -1.3, whoops, approximately. And a relative min, because the arrow goes down over here forever, so it doesn't have an absolute min. And that y value that occurred there was 0, and it happened at x equals about 1.2. All right, so a little more practice on that. Then we're going to talk about increasing and decreasing. Let me see. Is this the whole second half of the video? X-intercepts, Y-intercepts, increasing, decreasing. Well, I'm only at 18 minutes, so I'm going to keep going here. Increasing and decreasing. I will try to throw a slide in here maybe. If you come back and you need to find this. Shoot. All right, and you look beyond that lovely red slide to figure out where I started talking about increasing and decreasing. Oh, now I have the red slide in the wrong spot. There we go, I think. All right, so for the second half of the video, increasing and decreasing. This is really pretty easy because you just think of it as moving left to right. You always, always, always read the graph from left to right. So as I go along this graph, even though the arrow is pointing down, as I go from the left to the right, the y values are increasing, then they stay constant, and then as I continue off to the right, the y values are decreasing or going down. So again, as you read the graph left to right, increasing first, and this is a little bit weird, but you use X intervals to state where the Y was going up. The Y value is increasing. Okay, I'm going up from the left until I get to -1 here. The X value is -1. So it was increasing all the way until I got to -1. So I say from the left until -1. And you always use parentheses when you're doing increasing and decreasing, because at the end point it is neither increasing nor decreasing, so you don't need a square bracket. Good news, you'll never have to worry about square brackets on these. All right, then it is constant from the X value of -1 over to the X value of 1, 2, 3, 4. So from -1 to 4, the Y value remained constant. And then the Y values are going down. So you go left to right, the graph is going down, so it is decreasing. And that started happening at 4, and it goes off to the right forever. So we say to infinity. All right, these are X intervals again. You never use Y values when you're doing increasing and decreasing. The Y is what is doing the increasing or decreasing. All right, a few more examples. Remember, the important thing is you are reading left to right, and you're using X intervals to describe the behavior of what the graph is doing. So this graph, as I go left to right, is going down. So it is decreasing, coming from the far left, which would be -infinity, until I get to an X value of 1, 2, 3. And you also only need parentheses. All right, and then from 3 to the right, so I say from 3 off towards the right, where X values approach infinity, it is increasing or going up. Now, these can be a struggle for students, but just trace with your pencil. As you go from the left towards the right, this goes down. So it is decreasing from the left, -infinity, until this X value right here of 5, -5. But then something weird happens. If you go to the other half, just to the right of -5, look at, as I go left to right, it is still going down. Now it's getting closer and closer to some set value, but it is still said to be decreasing. It would be getting closer and closer to 1, but it might be 1.1, 1.01, 1.001. It's still getting smaller and smaller, closer to 1. So from an X value of -5 off to the right, it is still decreasing or going down. Again, the X value was the -5. All right. This one, as I trace from left to right, the Y values are increasing. Okay, so it is increasing from the left, -infinity, to the right, and it goes up forever, so to +infinity. The X values, no matter how far over this way I go or how far this way, all the Y values will be increasing. Now it looks like they're increasing very slowly here. They're just above, I can't tell what that is, -6 maybe. And then they begin to increase far greater quickly, but the whole thing is increasing. All right, now for increasing and decreasing, we really need to know those maxes and mins, because that's where it changes. So this one is decreasing, and then it's increasing, and then it's decreasing. But it changes at those maxes and mins. So for at least one or two of these, I'm going to use the graphing calculator to find, and again, we really only need those X values. If I was asking you maxes and mins, you would want both. But if I type this in, -x cubed plus 4x squared, and then it just says minus 2. Okay, do I have it typed in right? And I graph it. I need to know the ordered pair down here, which definitely looks like 0, negative 2, but I could test by doing a min. Number 3, go a little bit to the left, a little bit to the right, or I could type between negative 1 and 1. Now, I got negative 4.79 times 10 to the negative 7, which would be negative 0.6666, I'm sorry, negative 0.00000479. It's very close to 0. So that is a calculator error. Yeah, Hofbar's apparently evil. She starts quoting 6s. So this is 0, negative 2 at the min. And over here at the max, we need to find this ordered pair at the max. So we just second trace maximum. And I'm going to say it's somewhere between 1 and 5. I'm just going to type in a couple numbers. It's clearly in between those two. And it happens about 2.67. And the maximum y value is, I'm listing it this time, even though I don't need it, just because I want you to think about the fact that you don't use that number. Okay. So when you state increasing and decreasing, you only use the x values. So all of the y's are decreasing, coming from the left until we hit an x value of 0. And then it starts to increase in here between the x values of 0 and 2.67, where it's a max. And then the y values go jumping down, but it happens at 2.67 for an x value and off to the right, which is towards infinity. Again, draw these little arrows on your graph so that you remember decreasing is down, increasing is up, decreasing. These numbers are going to look confusing. Those are the x intervals where it is the y values are decreasing or increasing. All right, to save time and my brain, I'm just going to estimate. We're going to pretend this one happens at negative 2, negative 1, 2, 3, 4, 5, 6, 7. We're going to pretend this happens at 0, 1. That one looks halfway accurate. We're going to pretend this one happens at 1, negative 1. All right. Now, we only care about the x values of those maxes and mins when we're describing the interval where it's increasing or decreasing. We have to trace left to right. This one goes down, then it goes up, then it goes down, then it goes up. So we have two places where it is going down. That would be coming from the far left, negative infinity, until it hits an x value of negative 2, it went down. And then this little piece in here, the x values in between there where it was going down, were from 0 to 1. The places it was going up were between the x values of approximately negative 2 and 0. And then over here, okay, from 1 off to the right, would be 1 to infinity. Hope you're getting the hang of this. Okay. I'm just going to estimate real quick and call this one negative 1, 1, 0, 0, and over here 1, negative 1. Now, this graph is increasing, then it is decreasing. Now, it has a little 0, 0 hitch in the graph, but it's still going down all the way to here. And then it turns around and goes back up. So it was going up as I went left to right. Up is increasing from the left to negative 1. Then it was decreasing in between those x values. Again, the x value here and here. So from negative 1 to 1 going left to right. And then the x value of 1 and off to the right would be increasing again from 1 to infinity. Hope you're getting the hang of increasing and decreasing. All right. I think I'm going to go ahead and do these accurately on the calculator and record the notes and let you look at the notes, but I think I'm going to be done with the video. So do these on your own and then go to the posted slides of this video and check them, okay? These are looking for maxes and mins, and these are looking for increasing and decreasing. And these are looking for X and Y intercepts. You know what? I'm going to do these with you on the video. All right, so I'm on 11 and 12, X-intercept and Y-intercept, using the graphing calculator. So I am, oh, they're not. Oh, there's no equation given, so I can't. I just have to estimate. So the X-intercepts are down here at 1, 2, 3, 4, and 5. So you could write 4 and 5. It's actually over 4 and up 0. And over 5 and up 0 if you were to make them ordered pairs. The y-intercept is up here at 1, 2, 3, 4, 5, 6, 7, 8, over 0 and up 8. All right, I'm going to do this one just because it's a weird one. This one never touches the x-intercept. It has no x. It gets closer and closer from both sides, but it doesn't ever cross the x. It does cross the y down here at -2. Or if you went over 0 and down 2, the y-intercept, remember, always has x equals 0. These are the ones that are algebraic. All right. So if I type this one in my calculator, y equals x to the 4th minus 10x squared. Please be doing these. If you have to stop the video and record, and type them in and then turn it back on. But it's important that you practice doing this and getting those same values that I am. All right. Then if we graph, we get kind of a hot mess, but it looks like it's crossing the x a couple places and the y up here. It can only have one y-intercept. This is not a great window. I really can't see the bottom of the graph. So if you wanted to change the window further down, would be a y min of like -15 or 20. Now I can see the bottom of the graph a little bit better. Eventually we'll need to do that to find maxes and mins. This one only asks for x and y intercepts. Okay, if you remember, they're called the zeros when you're looking for the x-intercepts. So I'm going to go calculate, pick choice 2 for a 0. Now, I have to pick to the left and to the right. So this one, I'm going to say it looks like 1, 2, 3, 4. So between -4 and -2. I'm going to type the left is -4 and the right is -2. And it happens somewhere in between there. You're welcome to just scroll around and hit enter. It doesn't have to be exact. And it says -3 is a 0. Now, I'm going to cheat. If you think this one is at -1, you can literally type trace -1. How can you tell if it's exactly a 0? The y value will say 0, so it has one at -1. It also appears to have one over here at +1, which when I type trace, it does show up at 0 and at 3. And how do you find the y-intercept? Well, this is the easiest one of all because you go trace and type in a value of 0, or you can go second trace up here to calculate the value, choice 1, at x equals 0, and it'll find the y-intercept of 9. All right, so that one turned out pretty easy. Now you can do the same thing for this one. I don't really think I need to type this, but I'm going to show you because it has a square root. The graph can be a little bit misleading. Square root of x plus 4 arrow to the right, so I'm not in the box anymore, and then a -3. Now, I'm going to do a zoom 6 again. If I trace over to the left, this is really has nothing to do with an x or y-intercept, so I don't know why I'm showing you this. But notice there's no y value here. The smallest value we can take a square root of is at -4. And it does go through -4, -3. All right, moving on. The y-intercept is when x equals 0. So if I go trace 0, the y-intercept is at -1. If I want to find the 0 or zeros, somewhere over here it's crossing the x. So I'm going to go second trace, choice 2, and it's somewhere between 1 and 10. I'm not even going to be very picky, because it'll find it somewhere in there, and it is right at 5. So you could write those ordered pairs. If you go over 5 and up 0, you'll find a 0. If you go over 0 and down 1, you'll find the y-intercept. But it's okay either way. I'm not going to be super picky on that right now. Ooh, and this is just kind of fun. Relative or absolute. Okay, so I'm going to let you fill those in and then check your answers. I won't put that in the video. Is this the homework? Why do I have so many examples? Use your graphing calculator. Yeah. All right, I will finish these notes and you can check them, but I think that's enough examples for the video. And the homework, I believe, is a worksheet. Am I on 1.4 or 1.3? Anyway, check the assignment and the tasks for what lesson this is and what assignments. 1.4. I think there's a worksheet.